So we're on there?
Yes.
Hi!
Just saw your eye.
There I am. We're all recording. Righto. So this is the best we can do for working our way through. Me and Charlie. There's Charlie. She's recording me and we're going to try and help you out here. So question number 1 is, your 32-year-old female patient was stung by a bee. You're giving her 0.3 milligrams of adrenaline IM. How many mil to 1 decimal point do you draw up into the syringe? Now, one of the first tricks before we go too much further, I must say, this is a really, really wordy question. There's lots of stuff in there. There's only a few things that are really important. Number 1, your preparation is 1 milligram in 1 mil. And you see that I've got that written out as a ratio. Now, your patient needs 0.3 milligrams. Now, if you remember back to ratios, what you do on one side, you do on the other, okay? So what you do on one side, you do on the other. So what I did, to get to point 0.3, you multiply 1 by 0.3, and that gives you 0.3 of a milligram. If you do the same on this side, multiply it by 0.3, it will give you 0.3 mil. So in the answer, if I write 0.3, ta-da, we've got it right. So that's question 1. Question 2. Okay, just stop that right. Hi. Righto, so question 2. Your patient has overdosed on antidepressants. The ICP is giving sodium bicarbonate, 1 millimole per kilo, and the patient weighs 40 kilos. How many mil? So again, this is a ratio, 1 per 1 kilo. The patient weighs 40 kilos, so 1 times 40 equals 40. So you do that on this side as well, and the answer is 40 millimoles. So if you write 40 in here and check it, the answer is right. Okay. Question 3. Your 2-year-old patient is getting a Ventolin nebulizer for asthma. The patient weight is 14 kilos. The dose is 0.15 milligrams per kilo. The ampule is 2.5 mil. How many mil do you give 2 decimal points? Okay, so first and foremost, let's work out the actual the dose. So the patient is getting the patient's getting 0.15 milligrams per kilo. Okay, now we know that, so therefore, to work out the total dose, we know that the patient is 14 kilos, so it is 0.15 multiplied by 14. And the answer will equal, and I'll just get my calculator. Okay, so if I go 0.15 times 14, oh, I buggered that up, didn't I? Equals 2.1 milligrams. So the dose they need to get is 2.1 milligrams, but there's a second part to this question. The ampule, there is 5 milligrams in 2.5 mil. Okay, and our patient only needs 2.1 milligrams. So what we need to do is we need to divide both sides by 5, and that will get me 1 milligram in, and 2.5 divided by 5. I'll jump back onto my calculator over here. Just clear that. 2.5 divided by 5 equals 0.5. Okay, so in 1 milligram there's 1 milligram in 0.5 mil. What we now do, because we want 2.1, we multiply this side by 2.1, and either side of the ratio, what you do on one side, you do on the other. Okay, so 1 times 2.1 equals 2.1 milligrams, which is the dose that you need. And I'll just clear this. And then 0.5 times 2.1 equals 1.05 mil. So if I jump into my and go 1.05, check that, and we're right. These are sticky pages, Charlie. Okay, question 4. Okay, you're giving morphine to your 66-year-old patient with abdo pain. Per protocol, you are to dilute your morphine to a concentration of 1 milligram per mil. You administer 2.5 milligrams IV. How many mils do you give? Okay, so basically what you do and how you do this is really, really easy. And once you draw it up, it becomes sort of easier. But I'll draw a syringe. You get a 10 mil syringe. Now your dose, or in your morphine, you can see there's 10 milligrams in 1 mil. And what you do when you dilute this, you get your 1 mil of morphine and you dilute it with 9 mils of saline. So if I draw a syringe, as such, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that's basically a 10 mil syringe, okay, and labelled on the syringe 1 to 10. You have 1 to 10 increments. So you draw your 10 milligrams in 1 mil of morphine into your syringe, and that will then fill up this part. And then you draw another 9 mils of saline. So then your syringe will end up here. There was 10 mils of 1 mil of morphine mixed in with 9 mils of saline, which now means that you have 10 milligrams of morphine in 10 mil. Okay. And you need to give it 2.5 milligrams. So 2.5 milligrams is therefore 2.5 mil. And we're right. Okay, question 5. Your chest pain patient took three half tablets of GTN, okay, prior to your arrival. You give her a full tablet. How many milligrams has she taken in total? Okay, so 1 full tablet is 600 milligrams. So what she's had, you can do this a few ways, but let's do it as an equation, okay? She has had 3 half tablets, which are 600 micrograms. And then you gave her a full tablet. Okay. So if you break that down a little bit more, that's 3 times 300 plus 600 equals 900 plus 600 equals 1500 micrograms. But the question is asking you how many milligrams she's taken. Okay, so divide that by 1,000, it equals 1.5 milligrams. And that's the correct answer. That's always quite a trick. Make sure you understand the units the question is asking you to give your answer in. Question 6. Let's write divide by 1,000 there. Okay, question 6. Your 9-year-old unconscious diabetic patient weighs 30 kilos. You are to give a dose of 0.5 gram per kilo of 10% dextrose IV. How many mils do you give? Okay, so let's work our way through this. So let's work at the dose at the moment. So your patient needs a dose of 0.5 grams per kilo. Okay, so of 10% dextrose. So they're 30 kilos times 0.5, and that will equal 15 grams. Okay, but then the thing is how many mils do you give? And that then becomes a little bit, you need to know the dose of the dextrose. And we don't know that off what the information has given us here. So we need to have a bit of a closer look at the label. Now what I'm going to do is I'm going to just look up the protocol if I can find it quickly. Sorry. We'll work our way down through all the garbage that we need. You're a bit tired, Charlie. So we need glucose 10%. So, oh, there we go, glucose 10%. Okay. So if we look at the preparation here, it tells me that the glucose 10%, there is 50 grams in 500 ml. We need 15 grams. So what I'm going to do is I'm going to cheat. I'm going to work out what's in 1 gram. So I'm going to divide both sides by 50. So therefore 1 gram, 500 divided by 50 is going to be 10 mils. I need to know 15 grams, so I'll multiply both sides by 15. And I'll get 15 grams is 150 mil. Okay, so I'll go back into my questions, which is this one, and I will go 150, and we are correct. Question 7. You reconstitute the glucagon powder with 1 ml of solution in a pre-made syringe. How many milligrams are in 0.4 ml? Okay, so again, you need to know a little bit of product information about this. So I'm going to go back to the protocol, which is here, and the glucose, I think, is glucagon. I think that's up here. Glucagon. There we go. So 1 milligram, and you look at the preparation, 1 milligram vial, syringe, and a syringe containing 1 ml of sterile water. You dissolve the glucagon powder by adding the entire contents of the syringe into the vial containing the glucagon. So therefore you end up with 1 milligram in 1 ml. I'll write that down again as a ratio. So the question, we'll go back to the question. You reconstitute the glucagon powder with 1 ml of solution in the pre-made syringe. How many milligrams in 0.4 of a, how many milligrams are there in 0.4 of a milligram? I feel as though they've probably written the question wrong. They might have meant 0.4 of a mil or something like that. But essentially, let's assume they are. You multiply both sides by 0.4. And your answer is 0.4 milligrams in 0.4 mil. And so if we write 0.4, we are right. Question 15. A 15-year-old tourist has overdosed on heroin. Naughty boy. His mother says he weighs 77 pounds. The PEDS dose of Narcan is 10 micrograms per kilo IV or IM. How many mil to 2 decimal points do you give him round to 2 decimal places? All right. So there's a few different steps in this to use. The first thing we need to do is work out the patient's weight in kilos. So this is question 8. So what I'll do to start with is 77 pounds equals how many kilos? Because we need to know that. Now, I don't know what the conversion rate is, so I'm going to open up Goggle. I'm going to write LBs to kilo. You can see that there. And I'm going to cheat and just use their conversion and just go 77, and that gives me an answer of 34.9266 kilos. So I now know his weight. Okay? Righto. So that's aside. So back to the question, because that becomes important. The paediatric dose of Narcan is 10 micrograms per kilo, IV or IM. Okay? So that makes it reasonably easy. It's 10 micrograms per kilo, per 1 kilo. Okay? Now, I need to get it to 34.9266. So to do that, I multiply it by 1 by 34.9266. So what I do on one side, I have to do to the other. So 10 times 34.996 will be 349.27 micrograms. Okay. However, just to remember the trick, that's in micrograms. The question's now asking you, how many mil do you give? Okay, so this is why there's a few different layers to this question. So I now look at the dose. There is 400 micrograms in 1 mil. The easiest way for me to do this is going to be to divide both sides by 400. Okay, so I'll get 1 microgram and 1 mil where's my calculator gone? Back over here. Clear this. 1 divided by 400 equals 0.0025 mil. I then multiply this side by 349.27 and I multiply, so that's my dose, 342 micrograms, and so therefore 0.0025. I actually better clear that in case I've got everything. So 0.0025 multiplied by 349.27 equals, so that is 0.873175 mil. Then I'll go back to my question. Here it is. Okay, how many mil to 2 decimal points? So that will equal 0.87 mil. Come over here, 0.87. And they've got 0.88, which I would argue with, but if you're in an exam, I'd give you that right anyway. Question 9. Giving Maxilon for vomiting. To reduce side effects, you dilute it with normal saline in a 10 ml syringe. How many ml of normal saline do you add? What is your final concentration? Okay, so this goes back to your syringe, so I'll draw my syringe again because I feel as though that's sort of the easiest way to do this. So I'll draw my syringe. One, two, three, 4, 5, 6, 7, 8, 9, 10. My 10 ml syringe. Now I can see here that the dose of metoclopramide or Maxilon, same drug, is 10 milligrams in 2 ml. So I draw my 2 ml in of Maxilon there. So I have Maxilon into this part. I then need to draw it up to 10 ml. So therefore, that's 2 ml there. I need to get to 10 ml, so another 8 ml of normal saline will therefore mean that I then have 10 ml in my syringe. Okay, so therefore I will have a dose of 10 milligrams of Maxilon in 10 ml. So what is my final concentration? My final concentration, so I have 10 milligrams in 10 ml. They want to know my final concentration in milligrams per mil. So I divide both sides by 10. I have 1 milligram in 1 mil. Just remember, in a ratio, what you do to one side, you must do the other. So write 1, and my answer is hang on, I best go back and have a bit of a look at that because I don't understand. You are vomiting. Oh, okay. So I've only answered, and this is the issue, I've only answered the bottom question. I didn't read this properly. How many mil of normal saline do you add? And the answer is 8. So if we just, oh, we can do that later. But yeah, if we wrote in 8, that's how much that we would add. Righto. Read the question properly. Question 10. Your 80-year-old male patient is getting fentanyl intranasal for a hip fracture. The total dose is 120 micrograms IN. How many mil will you require? Okay, so there's 600 microgram in 2 mil. Okay, so often the easiest way just to do this is to work out how many mil in 1 microgram. So we'll divide both sides by 600. So in 1 microgram, there is, back to my little calculator. How you going, Charlie? You doing all right?
Yeah.
Okay. So 2 divided by 600 equals 0.003 recurring mil. Okay. So therefore, we need to work out 120. So we multiply this both sides by 120. That should be MCG. So 120 micrograms. Multiply this. The answer is 0.4 mil. So if we go back to the question, make sure I've read it properly. How many mil would you require? We would require 0.4. Phew, got one right again. Awesome. Now I can go?
Yes.
Excellent, righto. So we have seizing patients receive 0.4 mil of midazolam IM. The dose is 15 milligrams per kilo. How much does the patient weigh? So we're trying to work this one backwards. Importantly, to start with, you need to understand that the dose of midazolam, or the preparation of midazolam, there is 5 milligrams of midazolam in 1 mil. Okay? So this patient has received 0.45 mil. So therefore, they have received, and I'll just get my calculator going again. Five times 0.45, they have received 2.25 milligrams. Okay, so therefore, let's just run this one down. The dose equals 0.15 times the weight in kilos equals 2.25 milligrams, which is the dose. Okay, so just to make life easier, instead of writing weight in kilos every time, I'm going to call that X. So 0.15 times X equals 2.25. I'm going to divide this by 0.15. I'm going to divide this side by 0.15. It's what you do on one side of the equation, you do on the other. They cancel themselves out. X equals 2.25. Get my calculator going. Do this again. 2.25 divided by 0.15 equals 15 kilos. Hg. So I then go back over to this and write 15. Yay! We're all right. Your 4-year-old anaphylactic patient needs IM adrenaline. Mom says he weighs 40 pounds. How many mil to 2 decimal points do you need for an IM injection? And your dose is 0.1 milligrams per kilo. Okay, so again, we need to work out what 40 pounds is. So let's go to our converter, and must say, because I goggled that, didn't I? Now, so 40 pounds, you see it on there, equals 118.1437 kilos. Now, if the conversion is out by a little bit, the answer for this may be wrong. So don't get too upset. It might be that we're using the right one and the person who did it was wrong to a decimal point. But anyway, we'll keep going on. So let's work out the dose. Your 4-year-old patient weighs 18.14 kilos. The dose is 0.01 milligrams per kilo per 1 kg. So we need to multiply, so he's 18.1437. So if we, on the calculator, if we go 0.01 times by 18.1437, we will get 0.181437 mil. Sorry, we'll get 0.18, should have this over this side, milligrams is what we'll get. I was about to confuse myself there. Okay. Now, the adrenaline, the trick with this, which is reasonably easy, it's 1 milligram in 1 mil of adrenaline. 1 in 1,000 is 1 milligram in 1 mil. So 0.181437 milligrams will also equal 0.18 mil. Okay, so to 2 decimal points, let's see how we go. 0.18. There we go. Oh no. ICP, starting adrenaline infusion. He puts 1 ampule in 90 ml of normal saline. What is the concentration of adrenaline in micrograms? Okay, so your adrenaline, so what's his question 13? So what he's done, he's got 90 ml in a burette. So this is sort of what your burette likes, a little bit like a syringe. So that's 10 ml, 20, 30, 40, 50, 60, 70, 80, 90, and 100 there. So basically what he does is he gets 90 ml of normal saline in his burette, and then this last 10 ml he gets the bigger ampule of adrenaline, and it's 1 milligram in 10 ml, and then he draws that and that runs in. So what it ends up being is that there is 1 milligram of adrenaline in 100 ml of fluid. So divide that into, so basically 100 ml. So how many micrograms in per mil there will be? So if you divide that by 100 and divide that by 100, so I'll come into my calculator, it'll give me per mil. So 1 milligram, I must say this before I do this, 1 milligram is 1,000 micrograms. So I'll divide 100 micrograms, 1,000 micrograms by 100, which will give me 10 micrograms per 1 mil. Refer to question 13. Righto. So this is my infusion. The adrenaline infusion is started at 5 micrograms per minute. How many mil per minute is he infusing at? Okay, what is the infusion rate? How many mils per minute? So you have 10 micrograms. 10 micrograms are in 1 mil. So the dose is 5 micrograms per minute. Okay, so dose of 5 mcg per minute. How many mils per minute is he infusing at? Okay, so 5 micrograms is, so I'll just come back, I'll write this down again. 10 micrograms in 1 mil. So he's infusing at 5 micrograms per minute, so 5 micrograms equals 0.5 mils. Okay. And they're doing that, so the patient's getting 0.5 mils per every minute. So if we write that, 0.5, we are correct. Okay. Micro drips and all that. Your mini drop set is designed to deliver 1 mil as 60 drops. If you want to give 2.5 micrograms of adrenaline per minute, how many drops per minute do you run your infusion rate? So your infusion concentration is 10 micrograms per mil, which is what we worked out from question 13. Okay. So this is the last question, and it's 15. So we're running at a rate of 10 micrograms per mil. Okay, so we want to give 2.5 micrograms of adrenaline per minute. Okay, and so that will be 0.25 mil per minute. So 0.25 mil per minute is what we want to get your patient to get. Okay. So 1 mil equals 60 drops. Okay, we want our patient to receive 0.25. So probably write this out actually we can just do this. We want our patient to receive 0.25. So 0.25 multiplied by 60, so a quarter of 60 is 15 dpm, drops per minute. Let's see how we went. Alright, I'm going to cheat and look at the results now. Solution undefined. Righto. Okay. So what I'm going to do is go back through the drop per minute, question 15. I'm also going to go through question 10 and have another hard look at them shortly.